Yo, 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 yo! So after natin ma-discuss yung topic about applications using headless formulas, ngayon naman ay mag-discuss pa tayo ng continuation nito at ito naman yung tungkol sa three reservoir problems. At ito na muna yung magiging last topic natin for hydraulics. Pero hindi ko sinasabi na na-discuss na natin lahat ng mga essential topics about hydraulics. I-discuss pa natin yung ibang mga topics na hindi natin na-discuss ngayong first sem sa mga susunod na sem at sa mga susunod na courses. At since ito nga ay tungkol sa three reservoir problems, ay may involve na tatlong reservoir. So, pangalanan natin yung tatlong reservoir na yan as Reservoir A, Reservoir B, and Reservoir C. And these reservoirs are being connected by pipes. At since application nga to ng headless formulas ay gagamitin natin sa ating solution yung mga essential properties ng pipe gaya ng diameter, length, at yung mga headless coefficient. So, tinutukoy ko dito ay yung friction factor F for Darcy-Weisbach equation, roughness coefficient N for Manning's equation, at yung Hazen-Williams coefficient C for Hazen-Williams equation for head loss. At para ulit sa ating solution ay dapat particular din tayo dun sa elevations ng mga reservoirs. So, magre-refer tayo dun sa maintained level ng water surface ng liquid sa loob ng bawat reservoirs. So the pipes that are connected to the reservoir are being connected to a single junction. So that common junction is sometimes called as the piezometric zone or the piezometric point, wherein all gauge pressures are being concentrated at this point. And let's denote that common junction as common junction P. So upon representation of the net gauge pressure that is being caused by these three reservoirs, a piezometer will give us the value or the level of the pressure head that is being caused by these three reservoirs. At take note lang, itong tatlong reservoirs na to, Reservoir A, Reservoir B, and Reservoir C, have their distinct elevations. So, yung Reservoir A, yung pinakamataas lagi, saset lagi natin siya as Reservoir A. So, yung pinakamababa namang reservoir would be Reservoir C. So, babase tayo dito in terms of elevation. At sa pagitan naman ng A and C is the intermediate reservoir, which is Reservoir B. So, Reservoir A yung pinakamataas, Reservoir C yung pinakamababa, at Reservoir B yung reservoir na ang elevation ay nasa pagitan ng elevation ng Reservoir A and Reservoir C. Also, nailagay na rin natin yung designation natin for the pipe. So, yung pipe that is connected to Reservoir A is pipe number 1. Yung pipe that is connected to Reservoir C would be pipe number 2. At yung pipe that is connected to Reservoir C is pipe number 3. Pero bago natin i-compute o i-solve yung mga kailangang hydraulic properties for these three reservoir problems, ay alamin muna natin kung ano bang type of problem yung ma-encounter natin. So, yung una ay yung type 1. So, dito sa type 1 problem, yung discharge o yung flow rate is given to one pipe. So, alin man dito sa pipe number 1, 2, or 3, dapat merong given na discharge or flow rate. At yung required o yung unknown o yung mako-compute dapat natin ay yung mga required na pipe specifications or properties gaya ng D or diameter, length o yung head loss coefficient, o di kaya naman kung ang tinatanong ay yung elevation ng reservoir, wherein magre-refer nga tayo dun sa level ng water surface sa loob ng reservoir. So para naman dun sa problems which is under type number 2, ay given lahat ng specifications or properties ng tatlong pipes. So given yung diameter, given yung length, given yung F, yung N, or yung C. At yung required o yung kailangan nating makompute ay yung flow rate o yung discharge ng flowing liquid dun sa pipes number 1, 2, and 3. So summarize lang natin, para sa type number 1, kailangan may given kahit isa na discharge or flow rate malin dun sa pipe number 1, 2, or 3. At ang required ay yung pipe specifications or properties gaya ng diameter, length, head loss coefficients F, N, or C. Or pwede ring may unknown na elevation malin dun sa tatlong reservoir, Reservoir A, Reservoir B, or Reservoir C. Para naman sa type number 2 ay given naman lahat ng pipe specifications or properties ng D, L, F, N, or C pero ang unknown ay yung discharge o yung flow rate ng liquid na magfo-flow dun sa pipes number 1, 2, and 3. So, madidiscuss natin yung mga ways kung paano mag-compute dito sa mga specific types of problems kapag ka nag-solve or nag-compute na tayo ng mga example problems. So, hindi kasi lahat ng problem ay pare-parehas ng solution. So, depende din kung ano yung unknown at ano yung given. Pero maliban doon, ay meron tayong kailangang tingnang condition para doon sa system. So, meron tayong dalawang conditions na i-consider para mas mapadali yung ating maging solution. At malaman natin kung ano ba yung nangyayari doon sa system. So, dito meron na tayong figure para sa 3 reservoir system. So, dalawa yan kasi meron tayong dalawang separate conditions. So, para dun sa unang condition, say, meron tayong reservoir A, B, and C at yung common junction is junction P. So, A would be the highest in terms of elevation, C is the lowest, and B is the intermediate reservoir. So, maglalagay tayo ng imaginary na piezometer dun sa junction P. So, bakit mahalaga na malaman natin kung ano yung piezometric level? Kasi nga, ito yung magiging reference natin para dun sa head loss, para dun sa pipes number 1, 2, and 3. So, gaya nga na nabanggit, yung level ng water dun sa piezometer would be the reference for the major head losses para dun sa pipes 1, 2, 3. So, titingnan natin dito kung yung piezometric level ba is above or below the liquid surface at reservoir B. So, kung titingnan nyo, yung lines na nagko-connect dun sa liquid surfaces, dun sa reservoirs A, B, C, hanggang dun sa piezometric level o yung reference natin for head loss ay yung energy grade line. So, ibig sabihin nito, yung difference in elevation between the liquid surface at the reservoir at dun sa piezometric level represents head losses. So, yung difference in elevation ng liquid surface at reservoir A at dun sa piezometric level is H sub F sub 1. So, ito yung head loss due to pipe friction at pipe number 1. So, yung difference in elevation naman dun sa reservoir B at dun sa piezometric level is H sub F sub 2. At yung difference in elevation naman between reservoir C at dun sa piezometric level is H sub F sub 3. So, in this condition, kapag ka ang piezometric level is above the liquid surface at reservoir B, gaya dito sa ating illustration, ibig sabihin nito, yung reservoir A can supply on both reservoir B and reservoir C. Kaya kung mapapansin nyo, yung arrow nung flow nung A splits on pipes number 2 and 3. So, to put that into equation, pwede nating sabihin that Q sub 1 o yung flow rate at pipe number 1 is equal to Q sub 2 plus Q sub 3. Ibig sabihin nito, nag-split nga yung flow o yung flow rate from pipe number 1 papunta sa pipes number 2 and 3. So, yung sunod naman na condition ay kapag ka yung piezometric level is lower than the elevation of the liquid surface at reservoir B. So, ganun pa rin, pag pinag-connecta natin yung liquid surfaces at the reservoir, pati yung piezometric level, it will represent the energy grade line. At yung difference in elevation on the liquid surfaces at the 3 reservoir, pati dun sa piezometric level, represents the head losses due to pipe friction. So, H sub F sub 1, H sub F sub 2, H sub F sub 3 represents the major head losses at pipes number 1, 2, and 3 respectively. So, in this case, kapag yung piezometric level is below the elevation of the liquid surface at reservoir B, then B is not receiving liquid from reservoir A. So, ibig sabihin nito, nagsusupply din yung B papunta sa reservoir C. So, ibig sabihin nito, dalawa yung nagsusupply, reservoir A and reservoir B, papuntang reservoir C. And again, to put that into formula, we can say that Q sub 1 plus Q sub 2 is also equal to Q sub 3. At dahil nga magkatuwang o magkatulong yung reservoir A and reservoir B to supply reservoir C, then pag-addin nga natin yung Q sub 1 and Q sub 2. So just to summarize, titingnan lang natin kung nasan ba yung piezometric level para malaman natin kung ano ba yung direction ng flow ng liquid dun sa pipes 1, 2, and 3. So kapag by gravity lang yung ating condition, meaning wala tayong any input gauge pressure or yung mga equipment na magmo-modify ng pressure sa system gaya ng pumps, ay magsusupply lagi talaga ang reservoir A. Then, yung reservoir C naman ay lagi lang ding magre-receive ng supply of flow from reservoir A. Pero ang titingnan natin, ano ba yung direction dun sa intermediate reservoir, reservoir B? Yun ba ay supplying or receiving? So, yun nga, gaya na nabanggit, kung ang piezometric level is above reservoir B, then yung reservoir B ay magre-receive. Kapag ka naman yung piezometric level is lower than reservoir B, then reservoir B is also supplying to reservoir C. So kapag ka sinabing receiving yung reservoir B, ibig sabihin yung direction of flow at pipe number 2 is going towards reservoir B. Kapag ka sinabi naman nating reservoir B is supplying to reservoir C, yung direction of flow at pipe number 2 is going away from reservoir B. So ngayon, ang tanong naman dyan, paano kung lahat ng Q or lahat ng flow rate dun sa system ay hindi given o hindi natin alam? So katulad ito dun sa type number 2 problem. Kasi kung hindi given ng Q or wala kahit isang given na flow rate sa system, then paano natin madedetermine kung ano ba yung direction of flow dun sa reservoir B? So, ang gagawin natin ay kailangan nating matest kung nasan yung piezometric level. Nasa taas ba siya ng reservoir B o nasa baba siya ng reservoir B? Kasi yun lang naman yung makapagsabi kung ano yung direction of flow dun sa pipe number 2. So, ang gagawin natin ay iseset natin yung H sub F sub 2 o yung major head loss at pipe number 2 as 0. So, ibig sabihin, kapag sinet natin na yung H sub F sub 2 is 0, ibig sabihin yung piezometric level is with the same level at the liquid surface at reservoir B o dun sa intermediate reservoir. So, ang gagawin natin ay compute natin yung value ng Q sub 1 and Q sub 3 using major head loss formula. So, yung condition na to ay dapat given yung lahat ng elevations ng liquid surface ng reservoirs. So, kung hindi given yan, hindi natin alam kung ano yung magiging value ng H sub F sub 1 and H sub F sub 3. Also, dapat given din lahat ng pipe properties gaya ng diameter, length, at saka yung friction factor, roughness coefficient, or Hazen-Williams coefficient C. Para ang maging unknown lang dun sa ating solution ay yung Q sub 1 and Q sub 3. So, take note lang na yung mako-compute natin dito na Q sub 1 and Q sub 3 are not the final or the theoretical values of Q. Yung mako-compute natin dito na Q o na flow rate ay para lang dun sa test para malaman natin kung nasan yung piezometric level. At since hindi nga natin mako-compute yung Q sub 2 kasi nga 0 yung value ng head loss dito sa test na to. So, ngayon kapag na-compute na natin yung Q sub 1 and Q sub 3, pagko-compare natin yung values nila. So, kapag Q sub 1 is greater than Q sub 3 o mas mataas ang value ng Q sub 1 compared to Q sub 3, then reservoir B and reservoir C receives from reservoir A. O ibig sabihin nito, Q sub 2 moves toward reservoir B. So kung babalikan natin yung condition dun sa illustration natin kanina, papatak ito dun sa first condition wherein yung reservoir B ay nagre-receive ng supply from reservoir A at yung piezometric level is above reservoir B. So, yung general equation natin dito is Q sub 1 is equal to Q sub 2 plus Q sub 3. At base nga dun sa nabanggit natin na test, dapat yung value ng Q sub 1 is greater than Q sub 3. So, sa test na ang result ay Q sub 1 is greater than Q sub 3, ang gagamitin nga nating working equation is Q sub 1 is equal to Q sub 2 plus Q sub 3. Kasi kung titingnan natin, enough na yung flow from Q sub 1 para makapag-supply sa Q sub 3. And enough na rin yung supply from Q sub 1 para makapag-supply sa reservoir B. So yung last naman, kapag yung na-compute natin na value ng Q sub 1 is less than Q sub 3. So, ibig sabihin nito, yung reservoir B ay magsusupply na to reservoir C. Ibig sabihin, mababa yung value ng Q sub 1 na para makapag-supply ito on both reservoirs B and C. So, hingi na siya bali ng tulong from reservoir B para makapag-supply yung dalawa to reservoir C. Then, in this case, Q sub 2 moves away from reservoir B. So kung pagbabasehan ulit natin yung condition from our illustration a while ago, yung piezometric level naman in this case is lower than reservoir B. So kapag ka mas mababa yung piezometric level dun sa reservoir B, then yung direction ng Q sub 2 is away from reservoir B. So, yung magiging work equation natin dito is Q sub 1 plus Q sub 2 is equal to Q sub 3. And from the test, ito yung gagamitin natin kapag Q sub 1 is less than Q sub 3. At yun lang para sa video na to. Sana may natutunan kayo at see you sa next video. Thank you so much.